So if you recall, last class, we talked at length about the flights monolithic web service. That was a monolithic web service. And I walked through the code. We talked about the way it's laid out. What we're going to do now, we're going to assume that you know that. And I'm going to go ahead and run this particular code. So now I'm starting up the daemon running the flight application Spring web service, and it'll start up in a second. And then we're going to turn our attention over to the client side of all this stuff, just to show you how you can write client code to access this using some pretty interesting techniques. So let's go ahead and see that. So everything's up and running and it's happy. So now we're moving away from the IntelliJ project, and we're moving to a project that's using Android Studio and Android. So this is the client side of all this stuff. And I'm going to start by going ahead and running the app. So you can see that this is the login screen that's shown. And we type in admin with password pass. And what's happening under the hood, and I'll talk about this more and look at the code in a second. This is actually going to generate a login request using OAuth from the client application to that server that we had started up and running. So once that happens and we get authenticated with our account and password, now we've got the screen for finding flights. So this is the finding flight screen. And I'll show you how that gets set here in a second when we look at the code. So this allows us to choose between one-way trips and round trips. Let's go ahead and go, let's do some stuff here. Let's start from Nashville. And we're going to go from Nashville. And we're going to go to, let's go to someplace far away like Oakland. So you can see those are the airports. And then we're going to go ahead and set the departure and returning date. So here's the departure date. And here's the return date. So we're going to go from March 14th to returning on March 17th. This is again 2021. You can see now we've got our little screen set up and we can have as many passengers as we want. Let's just go with one. So at this point, we're going to click on Find Flights. And what'll happen there is that sends a request over to the flights monolithic web server. And it returns everything that matches that departure date and return date. And you can see that we have the departure date here. We've got prices. In this case, it's in dollars. And so we can choose which one we want. Let's say we want to go on this one. That's the later flight. And it gets there. And you can see that we have, actually it's not the later flight, it's the more expensive flight, but it's the one we want to take. And then we can choose the return flight. Let's go ahead and take that one. And then when we're done, you can see that it gives us a little screen that gives us the pricing information, and it gives us the kind of the itinerary. We depart and we get into Oakland, and we leave Oakland, go back to Nashville, and that's the great price of $1,380. And then at this point, if we click reserve, it comes and says, we've reached the end of this mock application. We haven't gone to the trouble of actually adding in a database, which would be very cool, but that's for the benefit of the reader. You can do that if you'd like to add extra features. So this is basically how this app works. And of course, under the hood, it's doing all kinds of cool things we're about to look at. So that's essentially the way that the app is laid out and how it works. So let's go ahead and close that. And then we're going to come in and take a look at the source code. And I'm going to focus primarily on the code that does the client-side communication from the Android app, which in this case is written in Java, to the server that's also written in Java using Spring. So to start out with this is the code. This is the view models. Those get called by fragments. There's a login fragment, for example, here. And you can see that when the login is created, it does a call that will build the login URL. If you go down here and we take a look at this particular class, this is using something called LiveData in order to implement the various features. And you can see that we've got some methods here. This is part of the code we'll take a closer look at here. This is requesting an authentication token to be logged in after giving the password and so on. And we'll take a closer look at what this is doing. There's this thing here called a data source. If you come up here, you can see a data source is an instance of something called remote data source, which is injected. So this is basically using Dagger and Retrofit and other dependency injection like framework mechanisms. And if we click on remote data source, you can see this is really the main proxy that mediates between the Android client application and our remote flights service. And we'll kind of take a look and see how all this works. This remote data source is going to be marked as a singleton, which means there's just one instance of it that's shared by all the components in the app. Don't have to do it that way. I just made it easier for our example because we only have one server we're talking to here. And we define ourselves an instance of something called a flight API. And I want to go look at that because that's really important. That's essentially an interface that provides methods for each of the endpoint methods that are defined by the server, the flights listing app server. And this is actually a mechanism that's using Retrofit, which is this really cool way of being able to have a lot of the code generated automatically to do the proxying from Java method calls in the client into the HTTP requests, GET requests, and so on that are sent from the client, in this case, an Android client, over to the server and returned back. So let's kind of take a look and see how this works. We've got some paths that are defined here that are essentially the endpoint method handles for describing where we handle authentication, logging out, finding the list of the airport's endpoint to find a list of all the airports, find a list of all the dates, find a list of all the flights, and so on. So these are just things that'll get used a little bit later. And then we've got various methods like request token, which is the one that we were just looking at for logging in. And you can see it takes a whole bunch of different fields that are used to go make a request to the client in order to be able to get the OAuth authentication set up. And there's a couple other things here that have to do with security. We won't talk about that right now. We'll talk about that later. That comes up soon in the lectures. What I want to focus on here really are more of the methods that are being used to actually call the business logic in the monolithic server. So here what we have is you can see we have a get annotation for the airport's path, which as you can see is to the airport's portion of the URL. So that'll end up being handled by the appropriate endpoint method in the server, in the flights controller. And you can see how we do here is we just say there's a method called get airports, and it returns a list of airport objects wrapped up in a single. Now, without getting too far ahead of ourselves, a single is a reactive data type that's used by the RxJava implementation. And we'll talk a little bit more about that. You'll see how that gets used here in a minute. But for right now, it's just a way of being able to do asynchronous communication. So this call to get airports doesn't block the caller. That's the key thing to note, the caller being the client code. We also have another method here that's called get departure dates, where you give it the departure airport and the arrival airport, and it gives back a list of strings that correspond to the dates for the departing and arriving for that particular set of airports. That also comes back as a single. It's a get request, and it uses the dates path, which of course is appended onto the other parts of the base URL to find the server. There's a find flights method where we give the departure airport, the arrival airport, the departure date, the number of passengers, and the currency that we're trying to use. Once again, that's going to make a call that goes back to the flights monolithic server to get the list of flight objects that match those parameters with the appropriate information here, like the currency and the number of passengers. And it also comes back as a single. And then finally, there's another way to do a log out, which is a post operation because it's modifying the server. So the typical rule is that get requests don't modify things, whereas post requests do. In this case, we're logging out. So that's the modification. And you can see we get back something called a completable. We'll talk more about that in a minute. Okay, so the cool thing about this, the thing I want you to note is that all this code here is going to be transformed by Retrofit by using the various annotations that you see here in order to generate the proxy code that's going to actually do the work of creating the appropriate type of REST template instance and getting that connected to the server and taking the parameters that are passed in and converting them to the appropriate HTTP encodings in JSON and sending that stuff over to the client, from the client to the server, getting the results back, et cetera, et cetera, et cetera. And so the neat part about that is we don't have to write any of that code. That's all done for us by Retrofit. So that's pretty cool. So let's take that and then let's go ahead back over here and we'll pop back up to the next piece of this thing, which is the remote data source. That's where we started looking at this thing. So remote data source is essentially the code. It's kind of intermediate code between this auto-generated Retrofit proxy flight API thing and the code that's running, that's doing the kind of the business logic and the view logic to display the results. Now, the first thing that has to happen here, of course, is we need to initialize that API, that thing that we just talked about up here that's called the flight API. And that's done here in the constructor. The constructor calls this factor method called build API. And build API uses Retrofit, which implements the builder pattern that you're undoubtedly familiar with. It goes ahead and it gives the base URL for the FLApp server, which in this particular case, I've kind of hard coded to my local machine. In real life, it would talk to some kind of endpoint or API gateway somewhere, but this is just to keep it simple. So we set up the base URL for the FLApp server. We then go ahead and build an OK HTTP client, and this HTTP client knows how to ultimately send requests from the Android client to the server. And it sets some things in here like the authenticator and the interceptor for the security protocol. It sets defaults on connections, reads, and writes. It builds this HTTP client. So that gets built here and stashed away. Then we go ahead and we tell this little Fluent interface chain we want to work with RxJava. So it'll be able to work with reactive types like singles and other types that you'd expect from RxJava, like completable and observable and so on and so forth. We're just working with singles here. We'll talk a bit more of that in a second. Then we go ahead and enable JSON encodings, especially for things like time and date. And then the final thing we do is we build ourselves a Retrofit object. And then we go ahead and take that Retrofit object and say, I want this Retrofit object to create an instance of the flight API class. So that's what's actually returned by this. So it does all this stuff generically. Then we give it the flight API class file or object, the class object, and we get ourselves a flight API, which is what is then stuck here, which will then be used by all the other methods that are in this code that we write. So here's what the code does. You can see the code is super duper simple. There's a get airports method that will be called. We'll see where that gets called in a second. It just forwards to the get airports method on the API, which is through the proxy. There's a get departure dates method here. It just turns around and forwards that to the get departure dates method on the API proxy. There's a method called find flights. It just goes ahead and forwards the flight request elements to the find flights method on the API proxy. And likewise, there's one for doing logouts. And when we're all done, we can go ahead and clear up all the tokens because we've logged out. And there's some other stuff down here, which I won't talk about now, that sets up all the tokens to do the OAuth authentication mechanisms. So let's go take a look now where these methods get called. And if we poke around, we'll see that they get called here in the main view model class. And I'll show you where that gets called in a minute. That gets called from the fragment code that makes up the Android app. As you can see here, the main view model extends the base view model. And this is what is implemented with RxJava. And it's used by all the fragments, by all the flight management fragments in order to do the various things that we need to do. So let's go ahead and take a look down here. And you can see this implementation is based on a technique known as LiveData, where you basically have these fields. And then as you set the fields, that has the effect of changing the view. I won't go into that right now. That's kind of beyond the scope of this focus. But if you're interested in seeing how you can write Android apps using the LiveData techniques, you might want to take a look at that. There's also an interesting field here called composite disposable. And composite disposable is a RxJava object or class for which we define an object. And it keeps track of all the various RxJava related operations so they can all be disposed of in one fell swoop. And you might ask the question, why do we need to do this? Doesn't Java have garbage collection? And the answer is it does have garbage collection, but we want to often get rid of objects when we no longer need them without having to wait for the garbage collector to run out of memory before it reclaims them. So it's basically a way to just kind of proactively initiate reclamation of things so they can be reused without waiting for the garbage collector to have to do it. There's a whole bunch of things here for LiveData. Let's ignore those for right now. And let's come down here and take a look at what we really care about. So we got this thing called airports, flights, and dates. And those are the things that we're going to be interested in being able to display. And actually, that's what we saw when we took a look at the user interface that we looked at initially, the one that looks kind of like the Southwest app on your iPhone or your Android phone. Here's the remote data source instance, which as you can see is injected. So we don't have to do that ourselves. That gets done automatically by the dependency injection framework. And then let's take a look at the various methods that are interesting. Here's one called request airports. And request airports gets called when the airport's fragment is initialized. So when the airport fragments view is created, this is how fragments work in Android. When that view comes into instantiation, the request airports method is called on the view model. And that's what triggers the information to go from the client to the server in order to be able to get back the list of airports and their flights that'll be arriving and departing. So we call request airports. That's what we're just looking at. So let's get back here. So here's what request airports does. And this is really neat. This shows how you can use the RxJava features, which we'll talk about later in the course. But here's a little preview of it. So we say, hey, data source, go out and get me all the airports. And what get airports returns, if you may recall, is a single to a list of airports. And without getting too far ahead of ourselves, a single is a reactive data type in RxJava that is, you can think of it basically as some kind of fancy schmancy future. And so it doesn't actually have to block the caller. It just comes back and says, okay, I've got a single to this thing. At some point, that value will have been completed and I'll get the results and the value will be emitted, which in this case will be a list of the airports. And you can see if you take a look, it's a list of airport objects. So everything's nice and strongly typed because of the fact we're using Retrofit and all the other magic to hide the low-level JSON or JSON-based encodings that are more string-oriented. So we get a single that emits a list of airport objects when that call completes. We then use the subscribe on operator in RxJava to say, run the call to get that list of airports in a background thread, in a pool of threads that's pre-allocated, and it's called the IO thread pool. And that's what schedulers.io indicates. It says, run this call in a background thread. Don't block the call. Now, what happens next is, this is really cool. This is one of the powerful features of using reactive programming in the context of a framework like Android. So we're going to do the actual call to get the list of airports asynchronously in a thread in the background pool of threads. And then we're going to go ahead and say, when the results are done, run the results of that background task that got the list of airports in the main thread. And Android schedulers.main thread is a factory method that returns the UI thread, the user interface thread. And that's where all the operations run in Android that need to interact with the user. All the user-facing operations run in the user interface thread. So subscribe on, do the operations to get the airports in the background, but then do the processing of the results on the UI thread, and the results are on success one thing, on failure another. So again, we'll talk more about this later, but the subscribe operator in RxJava is something called the terminal operator, and that is what will actually start all the wheels in motion to do this reactive stream. The other thing to keep in mind is that all this stuff is taking place in the background. It's not blocking the caller at all. So if things go well, if success occurs, then all we do is we take the list of airports we got back and we set the underscore airports live data field to the value to be the airports, which will then get populated and be able to be used by the app. But if something goes wrong, then the airport's error method gets called, and it'll basically print out the right kind of diagnostic based on what kind of error occurred. You can see there are different kinds of errors that could occur. So that's basically requesting the airport. And oh, by the way, we add this whole subscription here to the disposables field so that when the time is right, when we log out, all of those various elements can be cleaned up automatically without having to wait for the garbage collector to kick in. So that'll just kind of proactively do a better job of cleaning things up. So that's request airports. Let's take a look at some other stuff. Here is request flights. So after you've gotten a list of airports, then you can go ahead and make your request for the flights, from Nashville to Oakland on this day, leaving on this day, returning, number of passengers, blah, 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 blah. Once again, you can see that this is very stylized. So when request flights is called, and request flights is actually called in the depart fragment. So there's a fragment that handles departures. And you can see here that when that particular fragment is created, it does a bunch of stuff here, and then it calls query flights. And query flights, as you can see here, is going to turn around and call request flights. So query flights will then end up calling, it builds up the flight request, then it goes ahead and calls request flights. Now we're back into this main view model file. And what we do, once again, very much like what we saw before, we make a call to find flights on our remote data source. That forwards to the API. That, of course, sends the request over to the client. That returns, if you take a careful look at that, you can see that that returns a single to a list of flights. So it comes back as a single, which means all this stuff takes place asynchronously without blocking the client. We then subscribe the flight objects to run in the IO thread pool. So it'll do this request in the background. We then say, I want the results processed in the Android user interface thread, the main thread, in the Android schedulers class. Once again, we trigger everything with the subscribe terminal operation. If all goes well, we set the list of flights into the flights live data field. If something goes wrong, as before, we figure out what happened and print the appropriate error message. And then the last method I'll talk about here, although there's other ones, is the request departure dates method. This will asynchronously request the available dates from the server. So given a departure airport and arrival airport, this thing will make that call. If you take a look here, you can see that this is what's used in the calendar fragment, and that is what gets our departure dates. You can see that that goes ahead and does exactly what we did before. We use the data source to get the departure dates, which will give back a single to a list of strings after calling the API, method of the same name. As before, we do that in a background thread in the IO thread pool. We handle the results in the user interface thread, the main thread, by the Android schedulers class. If all goes well, we set the value of our underscore data live data field to be the dates, the list of strings that came back. And if something goes wrong, we have this data error method to handle that. So, and then everything else here is just basically setter and getter methods to return the appropriate portions of these live data fields as we need them. So that's basically what the application looks like it's really cool. Again, there's all kinds of other stuff here that has to do with the way that Android works that we don't really have to talk about in detail here. But if you're curious, you can poke around and see how it all behaves. But the thing I really wanted to focus on here was the way in which we use Retrofit to generate that Flight API proxy, the Flight API proxies from the Flight API interface. As you can see here, we have this remote data source, which is kind of this mediator or this proxy to the Flight API that puts things in the right format to communicate to the server. And then we have the main view model and the login view model. And these, especially, well, both of them actually use the RxJava features, especially the use of running operations in a background thread and the pool of threads intended for IO processing to be able to offload communication that's background communication off the user interface thread. You're not allowed to make networking calls from the user interface thread, for example, but you can make those calls from the background thread. And notice just how absurdly easy it is to write code that does this using these features of RxJava. So it's very stylized. We're making RPC calls here using Spring as the server implementation. We're running in the background. We're moving the results to the foreground. We're handling the results in either success or failure method references that can be parameterized to give you so-called behavior parameterization. So that's really what I wanted to show you, was what the client side of all this stuff looks like. We will come back later in the course when we get further along, and we're going to talk about other clients besides Android. And in particular, I'll show you some really cool examples of using various canonicalized client APIs and client tools like Postman and curl and so on, in order to be able to generate these requests and test out your endpoints. And what you'll also see that's really neat there is that we can either write our endpoint methods using synchronous types with WebMVC, which is what we're doing here, or as you'll see later, we can write the endpoints using the reactive approaches based on the flux mechanisms that are available with Project Reactor. And we can have all that stuff be completely transparent to the client as to whether it's synchronous or asynchronous, whether it's something like Postman or curl or an Android client. All these things are done in very clever and convenient ways. We can really decouple the client and the server side quite nicely.